Hello, welcome back to our series on Embabel Framework. So in our last tutorial, we covered the basics of MCP server. Then we created a very simple file operation based MCP server using Embabel. So today we will be continuing our journey wherein we are going to create a new MCP server that will interact with the REST APIs behind the scenes. So the MCP server that we are going to build is the Confluence MCP server. Now when it comes to the Confluence MCP server, we are going to create an MCP server that will interact with the Atlassian Confluence via their official REST APIs. Now using this MCP server, we can perform different kind of operations such as we can list what all different spaces we have inside our Confluence, and inside this space we can have n number of documents, so we can list down all the documents that are available inside a particular space. And if we have to create a new page, we can also do that using our MCP server, or we can even view the page history or metadata of any specific page that is available inside our Confluence. Now coming to our project structure, this is how our overall project will look like, wherein we are going to create a Spring Boot based MCP server. The name of our application will be Embabel Confluence MCP server. Now this contains the different set of packages and classes. So at the very top we have the Spring Boot main class. Then we have the service package within which we have created Confluence service class. Now this class contains the main logic for interacting with the Confluence using their official REST APIs. Then we have the MCP package within which we are going to create our Confluence MCP server, which will expose different set of tools for interacting with the Confluence. Then we have the DTO package containing the set of request and response classes that will be used throughout our application for performing different kind of operations. Then we have the config package within which we have one class named as configure open router models. Now when it comes to Embabel, it requires at least one model to be available, and in our case we are going to make use of the free model that are available via the open router platform, so that are defined inside this class. Now let's quickly go through our code base that we have written for our Confluence MCP server, starting with the pom.xml. At the very top you will notice we are making use of Spring Boot version 3.5.8. When it comes to Java, we are making use of version 21. And for Embabel, we are making use of version 0.3.0, which is the latest stable version that is available at the time of recording this video. Coming to the dependencies section, we have added the Spring Boot Starter Web dependency and Spring Boot Actuator dependency. Then we have added the Embabel Agent Starter MCP Server dependency. This is important. This dependency will bring all the things that are needed to create our MCP server. Then we have added the Embabel Agent Starter OpenAI dependency. Now earlier I mentioned that we are going to make use of the free models that are available via Open Router platform. Now when it comes to Open Router, their models are compatible with the OpenAI standard. That is why we have added the OpenAI dependency here. Then we have defined the two repositories for Embabel, one for release version and one for the snapshots. Coming to the application YML, at the very top we have defined the name of our application. Then we have configured the default LLM model for Embabel. In our case it is the Grok 4.1 free version available via Open Router. Then in order to work with Confluence, we need few basic settings like the Confluence base URL for your account, and then the API token in order to interact with the REST APIs. These values will come via the environment variables which we will pass while starting our application. Now coming to the Spring Boot main class, the name of our application is Embabel Confluence MCP server. This is the normal Spring Boot class which will bootstrap our Spring Boot application. Also it will register the agents that we have defined within our application, which in our case it will be the MCP server that we are going to see shortly. Now coming to the configuration package, here we have created one class configure open router models. This is the Spring Boot configuration class. within which we have defined the free models that are available via the open routers. So here you will notice this class is extending the OpenAI compatible model factory, and within this class we have specified the configurations related to open router platform, like we are passing the base URL of open router, then we have specified the API key which will come via environment variable, then we have defined the path suffix for the chat completion endpoint, and then we have specified the observation registry which will be provided by the Spring Boot actuator dependency. Now in order to make use of the free models that are available, we have to create the bean of type LLM. So here we have created the different beans of type LLMs. So since we are going to make use of the free model Grok 4.1, here we have created the bean for Grok 4.1, within which you will notice we are creating an instance of LLM wherein we need to specify the model ID, in this case Grok 4.1 fast free. Then we need to specify the pricing per token. Since these are the free models that are available, we have specified the pricing at 0.0. Then we have specified the name of the provider, which in our case is open router. Then we have specified the model cutoff date. Now coming to our service package, we have created one class called as Confluence Service class. This is the main class which is responsible for interacting with the Confluence via their official REST APIs. And in order to call our external APIs, we need the REST template. So this is what we are doing here. Inside the constructor, we are creating an instance of REST template within which we have defined the Confluence base URL, which will come from our application properties. And in order to interact with the Confluence APIs, we need the API token. So we are passing the API token via authorization header, and then we are simply initializing it. So now once we have the instance of REST template, we can interact with the Confluence. So here you will notice, in order to perform the different kind of operations, we have created different set of methods. For example, our MCP server can list down the different spaces that are available inside our Confluence. For this we have created the list spaces method. Similarly, for creating a new document, we have created create document method. For listing down the pages that we have created list document in spaces. And in order to get the history or metadata of a specific page, we have created these two different methods. Now if we view these methods, these are the simple methods which are making the REST call to the Confluence. So let's start with the list spaces method. Here you will see it will fetch the list of spaces from Confluence. So for this we are making use of the REST template. We are making the get call to the spaces endpoint, and whatever response we will get, we are mapping it to the string of object. So if you look at this response that we will get from Confluence, this is how it will look. So here you will notice we are making the REST call to the Confluence using their V2 API, within which we are trying to get the spaces that are available inside the Confluence. This will return the results in this format: key value pair. First key is the result, then we have the object, next key is the links, then we have the object. So this will be mapped to the string of object. And once we have the response, we will pass it to our MCP server. MCP server will pass it to the LLM, and it will simply return the response back to the user. Next we have the list document in spaces. So here you will see again we are making use of REST template, making a call to the get endpoint, and the endpoint is spaces. Then we will specify the space key and we will list down the pages that we have, and simply we will map the response to this class, which is the map of string comma object. Similarly, in order to create the new page or new document, we need to make the post call. For this you will notice we are making use of REST template. We are making the post call to the pages endpoint, then we are specifying the content using which we have to create our page. So here we have specified the request. Request is nothing but it contains the payload and headers. So here this is how the payload which Confluence is expecting, within which we will specify the space ID, the status, then the title of our page, and simply we will specify the page content using which we have to create our page. And these are the parameters that will be populated inside our payload, and using this payload simply a new page will be created. Then comes the page history endpoint, which is nothing but the get endpoint. We are making a call to the pages endpoint by specifying the page ID, and it will list down all the versions. And in order to get the metadata of a specific page, we need to make the get call using REST APIs to this endpoint, which is pages/page ID, and the response will be mapped to this particular class. So this is our main Confluence service class, which is responsible for interacting with the Confluence using the REST APIs. Now this service class can be utilized by our MCP server for performing various kind of operations. And in order to create our MCP server, we have defined the package named as MCP. Inside this package, we have created one class named as Confluence MCP agent. So this is our MCP server that we have created using the various annotations provided by the Embabel framework. Now our MCP server will expose various tools that can be utilized by the LLMs for performing any kind of operation related to the Confluence. Now let's go through our MCP server in very detail. In order to create our MCP server, we are making use of @agent annotation provided by the Embabel. Here we have given the description for our MCP server. Now since our MCP server can make use of the Confluence service, here we are injecting the same using constructor injection. And since our MCP server can perform various operations related to the Confluence, for each of them we have created a different methods. So here you will notice we have created methods like list spaces, list document, create document, get page history, get document metadata. So starting with the list space, this is one of the actions that our agent can perform, due to which we are making use of @action annotation. And the end goal for this is it will list all the spaces in the Confluence, and here we are making use of @achieves goal annotation. Now in order to make it available to the LLM, we are making use of @export annotation with the attribute remote equals to true, which will make this method available to the LLM. And then we have specified the starting input type. So if we expand this method, you will notice this particular method will list all the spaces that are available inside our Confluence. So in order to list all the spaces, we are making use of the Confluence service class calling the list spaces method. And once we have the response, which will be in this format, map of string of object, we are mapping it to the Confluence response Java record that we have created. So here you will see we have one field named as response, which is of type map of string of object. Now you will notice even though our method does not need any parameters, still we have defined the starting input type. This is because Embabel expects at least one of the input type to be specified, due to which we have specified the user input dot class. This is something which is already provided by the Embabel. Now for rest of the method, the core logic will remain the same, wherein we will make use of the Confluence service class, call the respective method to perform the kind of operation. And in order to expose them as the tool, we are making use of the @export annotation with attribute remote equals to true. So if we see the list document method, here you will notice we are making use of the Confluence service class. We are calling the list document in spaces. Now in order to list the document in spaces, we need the space ID. For this, you will notice we are accepting the input space key request, which is nothing but a Java record that we have created. And as an input, we will receive the space key. Once we have the space key, our Confluence service will list down all the documents, and we will simply map the response to the Confluence response class. Now since this method is expecting space key request as the input, we have specified the same inside the starting input type. Similarly, for creating the document, we need the space ID, we need the title of the page, we also need the content. So here you will see we have created one Java record named as create document request. It will contain space key, title and content. Once we have all three, we will make use of the service class to create the new document. Once we receive the response, we will map it to the Confluence response. And similarly, we have specified the starting input type as the create document request. Same goes for other two methods as well. We are exposing them as the tool to the LLM using remote equals to true. And in order to get the page history, we need the page ID. For this, we have created one Java record named as document ID. As an input, we will receive the document ID. Once we have the document ID, we will simply call the get page history Once we get the response, we are mapping it to the Confluence response object. And at the end, we have the get document metadata. For this as well, we need the document ID. Once we have the document ID, we will call get document metadata. And once we have the response, we will map it to the Confluence response object. So this is how we can create the Confluence MCP server. And in order to test our MCP server, we need to start our application. So I'll start our application, and then we can test our MCP server using one of the two methods. Like we can test it using the MCP Inspector, or we can test them using the MCP client, which in our case we are going to make use of the Claude Desktop. Now let's test our MCP server first using the MCP Inspector. So we have already started our MCP Inspector using the command line, and it is running on port 6274. And since our MCP server is already running, we will connect to the same using the server send event. So for this, we have specified the transport type as SSC. Then we have specified the URL. Our MCP server is started on port 8080, and the endpoint which is exposed by the Embabel Framework is /SSC, due to which we have specified the same. And when we click on connect, we should see the status as connected. And when we go to the tool and when we click on list tool, it will list all the kind of operations that our MCP server can support. So in our case, we have exposed 5 tools, due to which you will see the 5 different kind of tools here, like list spaces, get page history, create a new Confluence page, list document, get document metadata. So these are the nothing but the tools that we have defined here. For example, get page history, get document metadata, and so on. So when we click on list spaces first, what it will do, it will list all the Confluence spaces that we have. So on the right hand side, you will notice we are running the instance of Confluence, and if we see what all different spaces we have, so here you will see we have the 2 spaces, in our case Bunty Ragani and software development. So if we click on run tool, we should get the same response. So here you should see the name of the Confluence space, and here you will notice the name of the space is software development, and another space is the Bunty Ragani. And then if we have to see the different pages that we have inside any of the spaces, let me grab the space ID first, which is the 65772. So if we have to see what all different documents we have, we need to specify the space ID 65772, and when we click on the same, so it will list all the documents that we have. So if we have to verify it, we will quickly go to the software development space, and if we see what all different pages we have the page named as the template project plan. So let's see if we have. So here you will see the space is listed as the template project plan, which is also available on the right hand side. Now if we have to see the page history for this particular document, we need the page ID, which is 65923 in our case. So we will click on page history. So we need to provide the document ID 65923, and when we click on run tool, it will give the page history for this particular page. Simply, if we have to see the metadata for this page, we need to make use of the get metadata. So get document metadata, the document ID will remain the same, 65923. So when we click on run tool, we will get the metadata for this particular page. Now if we have to create a new page, we will click on create a new Confluence page. We will specify the space key as 65772. The content will be hello from MCP Inspector, and title will be MCP Inspector test. Today's date is 7th December. So when we click on run tool, we should get the response that the new Confluence page is created. Now if we refresh our page, we should see the new page inside this Confluence space. So here you will see the MCP Inspector test page is created with the content hello from MCP Inspector. So this is how we can test our MCP server as standalone using the MCP Inspector. Now the another way of testing our MCP server is using the actual MCP client. So here we are going to make use of the Claude Desktop. When we start our Claude Desktop, we need to first configure our MCP server, for which we can go to the settings and click on the developer tab, click on edit config. Here we need to edit this file named as Claude Desktop config, within which we need to specify how we can connect to our MCP server. So here you will see inside the MCP servers, we can define the name of our MCP server, which is Confluence MCP server. Then how we can establish the connection is using the npx, which is node. Then we will specify the servers and event endpoint for our MCP server, which is the localhost 8080/sse. Once the configuration is done, we need to save this file and restart the Claude Desktop. Now once the Claude Desktop is restarted, you can simply verify the connection by clicking on this search and tools. Here you will see our MCP server is listed with the name that we specified inside the JSON file, which is confluence-mcp-server. And when we click on this, here you will notice all the tools that are exposed by our MCP server are listed here. Now let's test our MCP server. So first we will request the Claude to list all the Confluence spaces. So Claude will send the request to our MCP server. Here you will notice a tool call will be made. So it is making a request to the list spaces tool that is exposed by our Confluence MCP server. So if we click on allow, we should get the two spaces as the output. First one is the software development, another one is the Bunty Ragani. So here you will see we are getting the expected output. Next we will request Claude to list down all the pages that we have inside the software development space. So list down all the pages that are present inside the software development Confluence space. So here also you will notice it will make a call to list document in space tool by specifying the space key, which is invalid. Here we are expecting the numeric ID, but initially Claude identified the space key as SD, stands for software development, so it should get an error. Then it will try to recorrect the same. Here it identified the space ID 65772. So now it will again make a call to list document in space endpoint with the correct ID, and now we should get the expected output. So here if you see, the pages that are present inside the software development space are these many. So on the left hand side you will notice all these pages are listed, like the template project plan, the template meeting notes, the weekly status report, test page creation using Claude Desktop. So all these pages are listed. Now let's view the page history for one of the pages. Let's test the page history for this. So again it will make a tool call to our Confluence MCP server, get page history, by specifying the page ID, and then we should get the expected response. So here you will see the page history is written. Now we will test our final operation, that is we will try to create a new page using the content and title. So here you will notice inside the software development we don't have any such page named as test MCP using Claude Desktop. So now when we click on hit, it should create a new page with this content, hello world. So here you will notice it has specified the title, content and the space key. Again it is invalid, so it will recorrect the same. So here you notice it is now using the space ID 65772. So the page is now created, test MCP using Claude Desktop with content as hello world. Now if we refresh our Confluence, the new page should appear here. So here you will see test MCP using Claude Desktop and the content which is mentioned is hello world. So also you will notice the timestamp is mentioned as just now, which means it has been created very recently. So this is how we can test our MCP server using Claude Desktop. Yeah, so this was all regarding how we can create an MCP server using Embabel Framework, which can interact with the REST APIs behind the scenes. For this, we have also created a detailed article which contains certain additional information like how we can obtain the API token for our Confluence APIs. Also, the example that we have seen in this tutorial is uploaded on GitHub. You can check out the code, configure your API keys and try the same. Yeah, so that's all from my end. I hope you found it useful. Thank you.